All right, so you're trying to find the max, so you write the equation. So the sum of the first and twice the second. So I wrote x plus 2y is equal to 100. And then when I'm trying to maximize the product, so this x times y is what I'm trying to maximize. Good? So I solved one of these. Did you solve for x or did you solve for y? Y. So you're going to say you're solving for y. So negative x plus 100. So you divide everything by 2. So y is equal to negative 1/2 x plus 50. And I put that over here. So I'm going to have x times y, which is negative 1/2 x plus 50 is equal to my function. When I distribute the x, I get negative 1/2 x squared plus 50x is equal to the function. Now I'm going to go ahead and take the derivative. When I take the derivative, I'm going to take 2 times the negative 1/2 and get negative x to the first plus 50. That's equal to my derivative. Set my derivative equal to 0. And I'm going to have x is equal to 50. And then if there's a place where the derivative is undefined, I need to find that, but there isn't. So I get x is equal to 50. Y would equal negative 1/2 times 50 plus 50. Yes? So I'm going to get negative 25 plus 50. So I get y is equal to 25. So my numbers are 50 and 25. To verify that this is a max, I'm going to go back up here and find the second derivative. So the second derivative is equal to just negative 1, right? Which means it's concaving down the whole time, which means it is a max. Everyone good? Okay, this one you have a square box, which means the base is the same. So here's my square box, x, x, and I'm drawing my box, and has an open top and holds 32 cubic inches. So this height is going to be different than these two dimensions. Does that make sense? So the volume of this box is going to be x times h. And they're telling me that the volume is 32 cubic inches. So 32 is going to equal x squared times h. I'm just going to hold that for a second. And then it wants me to find the dimensions that require the least amount of material, which means I need to find the minimum, and I need to find what of the shape. What kind of area? Surface area. So to find the surface area, I'm going to have this bottom portion, which is going to be the x, so x squared. And then I'm going to have 4 sides that are x by h. And then I don't have the top, so that's why there's only 1x squared. Does that make sense? So now this is what I want to minimize. So what I'm going to do is I'm going to go down here and I'm going to probably solve this for h and make this 32 over x squared is equal to h. So I'm going to put the surface area is equal to x squared plus 4x, and then the height is 32 over x squared. So now my surface area is going to be x squared plus 128 over x. So I'm probably, because I know I'm going to take the derivative, I'm going to rewrite that as 128 times x to the negative 1. So now I take the derivative of that, and that's going to be 2x minus 128x to the negative 2, which I could rewrite as 2x minus 128 over x squared. I'm going to set the surface, I'm going to set the derivative equal to 0. So I'm going to have 0 is equal to 2x minus 128 x squared. I'm going to bring this over, make it 128 over x squared is equal to 2x. What did you do at this point? So multiply both sides by x squared. When I do that, these will simplify and get 128 is equal to 2x to the third, divide. So I get 64 is equal to x to the third. Take the cube root of both sides, make it 4. So x is equal to 4. Then I would do the surface area. Let's see, it's undefined, and that's going to happen when the x squared is equal to 0 or when x is equal to 0. So I have two critical numbers, right? I have 4 and I have 0. Do my second derivative? Sure, why not? So here I'm going to take my second derivative to find out if they're maxes or mins. And when I do that, I'm going to have 2 plus 128x to the negative 3. Yes. So now I want to find the second derivative at, we'll do 4 first. So that's going to be 2 plus 128 over 4 to the third. That's going to be positive, right? And then I'm going to do the surface area at 0, second derivative, and that's going to be undefined, right? I don't think so, because I took a negative 2 times a negative 1. So this is positive, which means it's concaving up, which means it is a minimum. This one's undefined, because that's going to make my box non-existent. And so, well, what do you mean it's not? That's what I mean. That's why I pressed it. So do you get a height of 2? Yes. So my box is going to be 4 inches by 4 inches by 2 inches. Yes. Good. Good. Okay, this is going to be number 1 on the worksheet number 2. So a farmer wants to construct a pen using 200 feet next to a building. So you're first going to draw the picture. Now, no, it doesn't matter which one you label X and which one you label Y. When you do the calculations will figure out which one's X and Y. So if you look at somebody else's drawing and they labeled the Y across the top instead of what he did, that's fine. You're still going to get the same answers at the end. So he has 2 sides that are X, one side that's Y because the other side is the building. And now he's writing the equation for the perimeter because that's how much fence he has. And he's solving for Y. Why he's not talking.
Oh, actually talking.
Ooh. Because you want to maximize what dimension should the farmer use to construct a pen with the largest possible area. So the measuring stick isn't going to tell me whether I should make it like a 75, 75, and 50, or if I should make it 25, 25, and 150. Measuring tape's not going to tell me that. Common sense. It's the measuring tape. So I don't know what he's doing now. Oh, now he's doing X, Y. That's what he's going to try and maximize because that's the area. He's substituting in his Y. This is a really horrible color. I cannot stress enough.
I like this color.
I'm so happy.
Sounds like you guys just can see better. I can see it perfectly fine. Are you sure about that?
So it takes the first derivative, gets 200 minus 4x. I think the hardest problem is setting it up, right? You guys can take the derivative, no problem. If his x is equal to 50, now he's going to plug that back in to find his y. Y is equal to 100, so your dimensions are going to be 50 feet by 100 feet. Everyone good with that one?
Is it 50 or what? Can I use my finger?
Yes, I think you can. So number 2, your supermarket employee wants to construct an open top box from a piece of cardboard. So your cardboard is originally 14 by 30. And then you change colors.
No, I like this color. I like this color. That's a good color. Try white.
Okay, so when he constructs this, so he starts off with 14 by 30, and then you take out the little X by X sides. And when you do that, you carve those out so you can bend the box, bend the cardboard to form the shape. So now, see we center on what? You want it on blackboard with better handwriting. That might be good.
some people, other people might do it.
So can I just? Because you're trying to. Oh, I'm sorry, I wrote area.
That's the height.
X is
the height.
X is the height of the box. So when you have that box and you cut out the corners, this 30 is going to lose two of these X's, so that's why you get 30 minus 2X. This side of the box is going to lose 2X here, and then the height of your box is going to be whatever that X is, so that's why he has all those there. Now, why did he not have to substitute one variable in for the other? Because there's only one variable in this problem, right? This one's slightly different because there's only X, so that's why there's not that step where you have to solve one in terms of the other. So he FOILed everything, distributed the X, now he's taking the derivative. I can see. No, that's not right. 176. Okay, he waits. No, I just don't. Why scribble if you can erase? That's a life lesson. Okay. Yes. I'll have like today's notes or something. I don't know what I'll call something. It's not square. Because your piece of rectangle starts off 30 by 14. The sides that you carve out have to be the same height, so they meet. So one side is going to be 30 minus 2x, and the other one's going to be 14 minus 2x. It's not going to be a square base.
Okay. I know. Some people have feelings like that.
Yeah, don't understand.
No, me and Paul are on the same page. It doesn't.
Hey, what's your values? Justice, respect, integrity.
It doesn't stop Mr. Vada from insulting your
Actually, why don't you try that?
Why?
Oh. You're
Wait, Christian, watch this.
You're
Oh my God, push it in there. You can have as much paper as you want.
I'm not volunteering to court the accomplice.
You're doing a great job.
Oh, CP, they're saying he's just calling you out. No, you got the number one round, so.
Wait.
Oh!
What are the critical numbers should be 3 and 35 over 3. So now he's doing the second derivative because one is probably going to be the max, one is probably going to be the min. Does that make sense?
Sure.
So he's doing the second derivative and he's going to test 3 and he's going to test that 35 over 3, which is, I think.
That's the min.
So he's saying f of 3 is negative, so that means it's concaving down. Yes?
Yeah.
Which makes it the what? It's concaving down?
Oh, that means the max.
It means it's max.
He's a genius. He's a genius. Everyone using the network variation. I said 3 into.
So, okay. So your x is 3, right?
Yeah.
So I think it asks for what size should the square, okay, the x is 3, he did answer the question. But if you wanted to, and I don't think anyone really wants to, this would be 14 minus 6, so you would have 8. This would be 30 minus 6, which would be 24, and then 3. Those would be your dimensions. Does that make sense? The second critical number was at 35 over 3. When he did the second derivative, that ended up being positive, I believe, which means it concaves up, which means it's a min. And because actually that 35 over 3 will make it so that the box, like you're just folding the box in half. So you have no volume. I press that.
Alright, hello everyone, this is Zach Reading from, where's the, wait, how do I start writing?
Just your finger would start right
There we go.
That's a big line, man.
It is what it is.
So Rich wants you to construct 2 identical rectangle corrals using 200 feet of fencing, and you're sharing one side. So depending on how you label what your x and y is, you'll still get the same dimensions at the end. Does that make sense? So he has 4x, and that has to equal his perimeter, which is at 200 feet of fencing. Everyone good? And he's trying to maximize his area, which the way he wrote it is going to be 2xy is equal to the max. Now he's going to solve one for one variable.
Talk through this.
Yeah,
We plug the x in for the 4x plus 3, or wait, no, the 2xy. And then
So now he solved x in terms of y, and he's going to substitute that in for his area formula, which is the equation he's trying to maximize.
Wow.
Thank you, I appreciate that.
Let me go. Wait, hold on. Whoa!
And then we plug this y in.
Oh! No way. Is he gonna do it, Brent? I think he's gonna do it. I think he's going to.
We get fx equals -3 over 2y squared plus 100 y.
Oh! Why is no recording this?
Right.
Oh, yeah.
And then we take the
You
derivative.
need the first highlights.
Am I highlight real? Math class?
Yeah, it's your calculus highlights. Plan of the year.
Oh, so we solve for 0.
Yeah.
You're going to take the first derivative, set it equal to 0.
Tom Brady returns.
Trigonometry. minus 3.
Guys, stop disrespecting Jack. Let's sit down. Hey, sit down.
And then this is our y value. So then we do
Home run.
Hey, he's talking, guys. I did not hear a bell. Sit down.
This is what I was saying. You're disrespecting.
Who's group 4? Which one of you saved during my time to talk to the board?
I got places to be, people to see.
Make sure you get a review worksheet.
I like that class. Lots of fun. This is what I love
To be, people to see. And see homework today.
Can I round this now?
Yeah.
Okay.
Look it up, thank you.
Thank you.
Oh, it's so dense. Here. Joe, did you get one?
Done.
Technically, you would have to find the second derivative.
I already did that.
Oh.
It's not getting down.
Huh?
It's not getting down.
Did you just show it on here?
No, but it's not getting down.
So you do the second derivative,
It's just like,
and that's going to be
Negative
-3, so it's negative the whole time, so it's concaving down the entire time, which tells you that that's a max. X turns Y.
And then it tells us that x is 6 more than y. It says one's positive and one's negative, and it'll end up being positive and negative when we solve it down here. So we want to solve x3 in terms of one thing, so we're plugging that into here. 6 plus y times y is equal to f of x. And then distribute that, 6y plus y squared is equal to f of x. Now that we have that, we can take our derivative, so that the derivative of f of x is equal to 2y plus 6, and then we're finding the critical numbers, and so f of x is equal to 0. That's y is going to end up being -3, and then f of x is equal to undefined. That's not applicable, so that's not, you don't have to worry about that. And then it tells us that one of them is a negative rational number. So here's our negative rational number. Now we have to find a positive rational number. So to find a positive rational number, then we're plugging it back up into the original equation. So then x is equal to 6 minus 3, and that x is equal to 3. And so positive rational number is equal to 3. Our negative rational number is equal to -3. And then it asks us all the way to the top, what's the final product? So to find the final product, you multiply 3 times -3. And our final product is -9.